Hello everyone. In this lecture, I will introduce this course, Digital Control. What is the outline of this lecture? I will present the topics to be covered in this course, what textbook we will use, what approach of the textbook is useful to this course. We will have a brief overview of the contents in the textbook, conventions used in the Scilab code to be used in this course, and finally references. We will start with the introduction to modeling, introduction to digital signal processing, specifications for controller design, transfer function based control system design, PID control discretization, Smith predictor, internal model control, pole placement control, minimum variance control, and generalized minimum variance control. A follow up of that is generalized predictive control and dynamic matrix control. We will spend some time on state space control techniques also. All the techniques in the previous page are transfer function based. In state space control, we will discuss pole placement. We will discuss the concepts of controllability and observability, the important topic of separation principle, compensator design, linear quadratic regulator. This is the textbook that we will use in this course. It is a book that was published in 2007. It was brought in Indian edition in 2009. This book teaches digital control from scratch. So a student who does not have a great analog control background can also learn from this book or benefit by this course. It is suitable for students whose domain consists of only discrete time systems. For example, computing systems and supply chain systems. This approach gives another perspective to students who are good in analog control. I believe that it helps improve their understanding. It is also suitable for students who return to studies after a break. It helps think digital. What are the benefits of this approach? Filter design is easier than in continuous time. Identification is easier. It is easy to explain several practical control schemes in discrete control domain. For example, deadbeat control, minimum variance control, model predictive control, and so on. Designing directly in discrete time allows many features of digital systems to be used, and of course controller implementation also is easier in discrete time domain. The textbook has a detailed introduction to digital signal processing, but only in discrete time. It has a detailed introduction to identification. The above two alone can make a course. We derive controller specifications in discrete time. A large portion of the book covers transfer function approach to control system design. State space approach to control design is also covered in this book. This book has a large number of control system design techniques through computer programs. MATLAB programs are listed in the book. We also make available Scilab code. We shall use Scilab and Xcos in this course. However, Scilab programs have the same prefix as the MATLAB code, but with extension SCI or SCE. Xcos programs have the same prefix as the Simulink code, but with cos or Xcos or Zcos as the extension. I believe that the textbook is the manual for the programs. There is an index of the code at the end of the book. Finally, there are references that we use in this book. These are popular textbooks. The first one by Astrom and Wittenmark. The second one is by Franklin and Powell. And the third one is by Bogata. We have come to the end of this lecture. We'll see you again.